So welcome everyone. So this is the first lecture video of control systems. So by the control systems, you get to know after completion of this course, not this video. After completion of this entire course, you'll get to know about that how you can able to control a electrical system or a mechanical system, whatever it will be, based upon a transfer function based controlling or a state space based controlling, and also you can able to identify like it as a, how it can be works, and also how it will be exhibits like its properties like a way, both in the time domain and also frequency domain. And also you can able to for example simply like saying like it as a, if you take a one system means whether you can easily understand like it as a, in that total system what are the electrical quantities and also what are the non-electrical quantities based upon the total instrumentation knowledge itself. Okay, so in this total video itself we are going to cover the topics to be covered is basics of elements in the total control system, and also what is exactly the open loop system and what is the control closed loop system, and also what are the basic real world examples, and also what they are differ, how they are differ on these things. Okay, so what is a basically a control system is a control system is system simply it can say like it as a one of the system is either it can be a converter or either it can be a motor or either it can be anything, any electrical behavior system or a mechanical behavior system like motors, generators, or anything which is converted or which is driven through a electrical model. So it need to be controlled, because why it need to be controlled means if it is not controlled, simply I will tell an example. If the high voltage is coming to your home means, then if you don't have any control over that one, if you don't have any safety precautions over to that one means, then what will happen is the high voltage will come to your home, then what are the equipments will be there, the total equipments will be get damaged. So that means we need to make sure that like it is, it's a simply like it as a safety, and also for every one equipment it need to have like it as a same basic that voltage only it need to be needed. Like for example, if the charger is there, the charger needs only input voltage of this much of voltage only will be there. And the same way every equipment like if even the refrigerator, even the AC, there are different current ratings will be there, there are different voltage ratings also will be there. So based upon that one, so whatever the input voltage also, it doesn't matter, we need to give the output to be in a controlled way. So to control that one we need to use a closed loop system. If that is not needed, we can use a open loop system. What exactly open loop system means, that we will discuss. So how exactly the control system will works means, there are multiple things will be there in actually the stages of the elements we can classify it as. So input, what is the basic input will be. So either it can be a desired value, that means what is the value it need to be, a reference value or an actual value, or a command value, or a controller. Controller means wherever it will be totally the system is controlled, that is called as a controller. And actuator, which can execute the control signals. If the controller is there and it need to be execute that signals, that is called as the actuator. And what is the plant is called as a total physical system. That means if it is a refrigerator, or if it is a mobile operating system, or if it is a converter, or if it is a motor, or if it is a generator, whatever it is, those are all called it as a physical systems or plant models or process we will call it as. And output is the what are the output we will having it as either it can be voltage or the speed of rotating of a machine, or it can be a current, or it can be anything. So feedback means whether it need to be compared to get a closed loop or a desired voltage. So whenever we are using a closed loop system, the feedback will be utilized. If the not even the closed loop, then we don't use the feedback signal will be there. So the simple block diagram of this total elements will be like this. So wherever if you see here, so the things whatever it the input will be there, and also error detector will be there, and error signals. These are wherever these things will be there. So this input and also feedback signal and these things total it will be acting like it as a closed loop system. That means we are designed to get a desired amount of voltage or current or whatever it will be. So that feedback signals whatever will be there, this feedback elements will be considered only in the closed loop. So here if you see, this is the controller and this is the plant which is driving to be, and here from this controller itself the plant is getting controlled, and by that one itself we can get the desired output things. So when it comes to the, for example, if we see a basic whatever example, if it is means we have a basic example like it is a room heater. If you see the room heater, what are all the things will be there? The room temperature we can able to set, and the temperature can be whatever the controller is. The controller is operated with the thermostat, And what is the actuator means? That is a heating coil. The what are the coil it will be? That is the actuator coil. That means it is executing the thing. And plant means it is a physical system. That means our room temperature, also room. So and actual output means actual room temperature. So it will be both. It will be monitored. So room temperature it will monitor, and also it will take the considerations of the what how much you want to keep. For example, if you a room heater and also both will operate in the same way. So temperature sensor will be the feedback signal. How it will be exactly operate means if you see this block diagram itself, you can simply understand like it how exactly it will operate. So this is the block diagram of a room heater, which is normally generally we see in many places like it in basically in Delhi region we will see many things. And after that, what exactly the open loop control system is? The system where it doesn't have any feedback and also it is not even controlled. Then it is call it as an open loop system, and also it is not corrected. But the most disadvantage thing is we can't able to control first thing, and also it is not able to correct it, and it is not having accurate results, and it is not able to do anything. But it is a very less cost basically because we don't have any controllers included in this one. If you see, this is the complete block diagram of the total system. So input signals will be there, and after that a controller will be there. And here nothing is we are not taking any feedback here. So that is why it is called as an open loop system. The same thing it will be reflected in the closed loop control system also. When it comes to the closed loop control system, whatever will be there means, so to get the desired output voltage, we need to get the feedback signal. So that feedback signal is coming to this one. So input signal will be there, and this error will be having a reference minus whatever the feedback, and this is called as error detector, and this error will be fed to the controller, and this controller will be connected to the controller will give the commands, and it will execute whatever the things will be, whether it need to be having a mathematical model or it need to be a digital manner. So then after that it will give the input signals to the plant or process to give the desired output voltage or desired output current or desired output speed or whatever it will be. So according to this one, it will operate. But the one of the major disadvantages, so it is having very complexity and also it will be very costly because this controller is having a thing plays a major role. So that's why it will have a more cost will be there, and also complexity will be get very high. And next thing is, but it will have a very accuracy will be there, and also automatically error corrections will be there. So this is how it will be happen. Then next will be the if you see what is the basic comparison, if you compare both open loop and closed loop means how it will be there means. So if you see open loop will be no feedback signal will be there in a conclusion really, and also simple, easy to easy to implement, and also less accurate will be there. But closed loop will be it is having a feedback signal will be there, very accurate will be there, and adaptive will be there. In the open loop system, what are the examples will be there means like bread toaster will be there, washing machines, these are all things will be under room heaters, these are all things will come under this one. But when it comes to the closed loop system means like a cruise control, that means cruise control means simply like it as a vehicle control system or a vehicle control, whether a well, whatever the vehicle it will be, like for example like it has a EV vehicles or a rockets or whatever it will be. So both are all are comes under cruise means it is like it is a moving vehicle based things will be there. So and the ACs and each and everything will coming into this section. So then finally conclusion. So if you see to the conclusion means the what are the conclusion means of this video is it is a basic thing like the control systems are very much essential in an automation field. Automation field means wherever the system is controlled automatically by the user. That means when we want to control, for example, simply like it does if the AC temperature need to be set to the 16 degrees or either it need to be set to be the 20 degrees, we are setting it and automatically it need to take a signal and it need to give the output or say give the temperature like it is in that field only. So that is that type of things are called as the automation. So in that again in the simple like examples like it as in our refrigerators also we will set the temperatures, or many places we will set the things like it as whatever the desired things will be there, that type of things are called automations. And also whenever it will be there, if it is needed for a closed loop or open loop. For a simple example for an open loop system will be like it as a we can say it like it as our fans where we don't have a control, and some fans we have a control. So these are all things also will be there. Fans are like it as a wherever you can feel like it as it will be a regulator will be there, but regulator is not a fully control system, it is a semi-regulated control system. So this is how it will be operated. So both will be in the open loop system and also control closed loop system. So finally, this is the first video, and the second video will be continued to the next slide. Thank you.